Today we are studying the topic named types of diode. So we have rectifying diode and Zener diode. So what is diode? Diode is a two-terminal electronic component which generally allows the current in a one direction. So this is the symbol of diode, having anode and cathode terminals. Anode show with the positive sign and cathode is with the negative sign. So this is the symbol of rectifying diode or PN junction diode. There are different types of diodes, which includes rectifying diode, that is PN junction diode, then Zener diode, light emitting diode, and photodiode. There are also other types of diodes, includes gun diode, tunnel diode, Schottky diode, varactor diodes, etc. So other types we don't have any study of them. So we have to study all of above stated four types, in which first is the rectifying diode. So rectifying diode is a again two terminal device with P and N junction, P and N types of semiconductors with terminals anode and cathodes. So this diode is also called as the rectifying diode, since it is used for the rectification purpose. So what is rectification? To convert the AC power into the DC, called as the rectification, and the circuit which converts the AC voltage or AC power to the DC power, called as the rectifiers. So in rectifiers these diodes are used, so it is called as the rectifying diode. Look at the different modes of the diode. So diode can be connected in a forward bias mode. So what is forward biasing? Look at the diagram. So in diagram, when positive terminal of battery is connected to the anode of diode and negative terminal of battery is connected to the cathode of diode, then it is said that diode is connected in a forward bias mode. So this is the forward biased mode connection, and similarly we have the reverse biasing mode. So opposite to the forward biasing, reverse biasing is there when a positive terminal of battery is connected to the cathode of diode and negative terminal of battery is connected to the anode of diode, then it is said that diode is connected in a reverse bias mode. So look at the figure. Positive terminal of battery is connected to the cathode and a negative terminal of battery is connected to the anode. So only the supply is changed, terminals are changed as like the forward biasing. So this is the reverse biasing. So what is the effect of forward biasing on the diode, and what is the effect of reverse biasing on the diode? So for this we have to study this figure. So same connection is there for forward biasing, but p-type region is shown here, n-type region is shown here, depletion region is also shown here, and holes within the p-type semiconductor, electrons within the n-type semiconductor are also shown in this figure. So for our simplicity we are showing this diagram. What is the action inside the PN junction diode when we connected the diode in a forward bias mode? So when you look at the p-type semiconductor region, so there are holes with white and gray color shown here, which is in majority numbers, or it is called as the majority charge carriers. What is majority charge carriers? When holes in the p-type semiconductor are in major quantity, maximum quantity, since it is called as the majority charge carriers. But when you look at these orange dots, orange circles, they are free electrons, but they are in less numbers. So these are the minority charge carriers, small in numbers. So p-type semiconductor having holes are the majority charge carriers and electrons are the minority charge carriers. Similarly, in n-type semiconductor, free electrons are the majority, means in max numbers, and holes, that is positive charge carriers, are in a small numbers since it is minority charge carriers. So I am listed below the table for that also. And in middle region, that is depletion region, we have the immobile ions. So negative ions at the left side, positive ions at the right side, in a narrow depletion region. So what is the action when we apply the voltage? So we study similarly what is the action inside the PN junction diode when it is connected in a forward biasing mode. So when we increase the voltage in a step of 0.1 volt, so we have to apply the voltage by using battery. So we have to increase the voltage in a 0.1 volt of step. So 0.1 volt, 0.2 volt, 0.3 volt, like that we have to apply the voltage from the battery. So what is the action inside the PN junction diode? So look at the diagram, and I'm explaining it in detail. When we are applying the 0.1 volt to the battery, so to the diode, then positive charges from the positive terminal of battery are collected at the anode. So when we connect the battery, means they are also ions, positive and negative charge. So positive charge of battery is accumulated at the anode, and negative charges from the battery is also accumulated to the cathode, that is n type semiconductor. So already we p-type semiconductor with positive charges, that is holes, and n-type semiconductor is with electrons. So what is the action? The positive terminal of battery repels the holes towards the junction. This is a junction or depletion region, and negative terminal of battery is connected to the cathode. Hence these negative charges of battery also repels the electrons from n-type semiconductor to the depletion region. So what is the action? By repelling the both type of charges from p-type, holes are repelled towards the junction. Also from n-type, electrons repels towards the junction. So what is the action? By repelling the carriers or holes and electrons towards the junction, what is the action inside the depletion region? Holes of the p-type semiconductor are combined with the electrons of the depletion region. त्यामुळे काय होणार आहे? Some neutral charge are created when we consider the hole. Then there is a deficiency of one electron, and when you consider the fulfill of this one deficiency of electrons, then atom will get a neutral charge. So like that, when holes are combined with the ions of the depletion region, then it creates the neutral atoms. So the layer of that depletion region, negative ions, is decreasing. Similarly, When the electrons from n-type semiconductor, they are repelled into the depletion region, then some positive charges are again recombined with these electrons, since uh, positive negative charge are there, and hence the depletion region from the n-type semiconductor also decreasing. So by repelling the both opposite charges of opposite charges into the depletion region width is goes on decreasing. तर ही डिप्लेशन रिजन विड्थ काय होत जाणार आहे, डिक्रीज होत जाईल. आणि ते होत असताना वेन यू अप्लाय द व्होल्टेज 0.3 व्होल्ट फॉर जर्मेनियम, 0.7 फॉर silicon, then what is the action at one stage, that is at 0.7 volt, then all the depletion region gets vanished. Why it is vanished? Since all the ions, immobile ions of the depletion region, that are combined with the holes and electrons of the p-type and the n-type region, hence all the depletion region get vanished, and maximum number of electrons flows from n-type semiconductor, that is from battery to the n-type semiconductor to the p-type semiconductor and to the positive terminal of battery. Similarly, holes are flow from p-type semiconductor to the n-type semiconductor and negative terminal of battery, and hence maximum current is flowing through the diode from anode to cathode. So conventional current is considered to be flowing from the positive terminal of battery to the negative terminal of battery. So this is the positive, this is the forward biasing mode in which the current is increasing like that. So for that we have to look at the figure. In first quadrant, we have voltage axis is there, Vd for diode voltage and Id for diode current. So this action is inside the diode is taken place. So up to the 0.7 volt a small current is flowing through the diode, and at 0.7 volt maximum current is flowing through the diode. So at 0.7 volt this is considered to be a knee voltage, and definition of knee voltage is that the voltage at which current flowing through the diode is increasing rapidly, that voltage is called as knee voltage. तर हे knee voltage ला का होतं, since knee voltage is equal to the barrier potential. जे काही डिप्लिशन रिजन असतो त्याचं जे बॅरियर पोटेन्शियल असतं ते 0.7 व्होल्ट असतं फॉर सिलिकॉन and 0.3 for germanium diode. When we apply the 0.7 volt to the silicon diode in forward bias mode, then this depletion region get vanished. So maximum current is flowing from anode to cathode with the forward voltage. So when you increase the voltage, after that current is also increasing. So this is the forward bias mode. Similarly, we have the reverse bias mode. Before that we study the some characteristics. In forward bias mode, that acts as a closed switch. Closed switch म्हणजे काय, चालू असलेलं बटन, चालू असलेला switch. So when switch is on, then maximum current is flowing from one terminal to the other terminal. This is the function of switch. So when diode is connected in a forward bias mode, it acts as a switch and it offers a very low resistance. ज्यावेळेस एक डायोड काय होईल, फॉरवर्ड बायसमध्ये असेल तर तो एकदम कमी रेजिस्टन्स काय करतो, ऑफर करतो. सो दिस आर द सम कॅरेक्टरिस्टिक्स ऑफ डायोड. सो अगेन we have to study the reverse biasing mode also. So what is the reverse biasing mode? So connection is already shown in above slide. But what is the action when you connect the diode in a reverse bias mode? So look at the figure. We have reverse biasing mode again. So this is the reverse biasing mode. So in reverse biasing mode, the positive terminal of battery is connected to the cathode and negative terminal of battery is connected to the anode. So what is the action when we have this type of connection? So I am looking for the diagram. If diagram is there, I will explain from the diagram. So I think diagram is not there, but from the same slide I can explain. So what is the action in reverse biasing mode? So when you consider the positive terminal is connected to the, actually terminals are then get changed. So I'm not referring this figure, since it has positive and negative terminals as like the forward biasing. So I'm referring this figure for your understanding. So in reverse biasing mode, what is the connection? Positive terminal is connected to the cathode and negative terminal is connected to the anode. So what is the action? Since in n-type semiconductors, holes are there, electrons are there, and we are connecting here positive charge. So this supply connection are reversed. So what is the action? Actually, the electrons from n-type region is flows, or it is attracted towards the positive uh, terminal, since supply are reversed for this figure. And similarly, from the p type region, holes are attracted towards the negative terminal of battery. So this type of connection is there. So what is the action? So when the holes are attracted, electrons are attracted towards the battery, so the depletion region width goes on increasing. जी काय डिप्लेशन रिजन विड्थ आपण दाखवतोय ही काय होत जाते, इन्क्रीज होते, कारण होल्स हे बॅटरीच्या निगेटिव्हकडे अट्रॅक्ट होतील, का तर सप्लाय आपण रिव्हर्स केलेत, आणि इलेक्ट्रॉन्स हे सुद्धा काय होतील, दे आर अट्रॅक्टेड टुवर्ड्स द पॉझिटिव्ह सप्लाय ऑफ द बॅटरी. सो द डिप्लेशन रिजन विड्थ गेट इन्क्रीज्ड. डिप्लेशन रिजन विड्थ काय होत जाते, वाढत जाते, and hence the current flowing through the diode is stopped completely. जो काही मॅजॉरिटी चार्ज कॅरियर्समुळे फ्लो होणारा करंट असतो तो काय होतो, पूर्णपणे स्टॉप होतो, का तर रिव्हर्स कनेक्शन्स केलेले आहेत आणि सगळेच्या सगळे होल्स आणि इलेक्ट्रॉन्स हे परत बॅटरीकडं अट्रॅक्ट झालेले आहेत सेमीकंडक्टर मटेरियलमधले, and hence current is stopped completely. But look at the minority charge carriers inside the p-type semiconductor as well as in n-type semiconductor. तर हे minority charge carriers कसे असतील? So that I have given here one chart. So when we have p-type semiconductor, holes are the majority charge carriers and electrons are the minority charge carriers. When you consider the n-type semiconductor, electrons are the majority charge carriers and holes are the minority charge carriers. So from this table and from this figure, holes as well as electrons, they are attracted towards the battery, and some minority charge carriers, that is electrons from p type and holes from n type, they are repelled towards the junction. हे रिपेल होतील, बाकीचे काय होतील, अट्रॅक्ट होतील, and hence some small leakage current is flowing from the anode to cathode, or we can consider from cathode to anode, since positive terminal at the cathode. So a small leakage current is flowing from cathode to anode due to the minority charge carriers. when we increase the voltage in a step of 1 volt, 2 volt, 3 volt, 4 volt, then this minority charge carriers current due to the minority charge carriers is also increasing very slowly. And when you apply the reverse breakdown voltage like 15 volt like that, then due to the maximum voltage the depletion region gets damaged or breakdown, and maximum current is flowing from cathode to anode. So look at the characteristics up to the reverse breakdown. VBR, voltage of reverse breakdown, the current flowing through the diode in reverse mode or reverse leakage current is very small. And when we apply the reverse breakdown voltage, then maximum current is flowing from the cathode to anode due to the breakdown of PN junction or depletion region. So these are the characteristics for forward and reverse biasing. So in reverse biasing mode, diode offers a very high resistance. We can consider in reverse biasing mode, diode acts as an open switch and it offers a very high resistance. So these are the IV characteristics for rectifying diode. It is not for the Zener diode. So when we have the question like that, explain. This is not question since we have the online exams. So some points will be summarized here. So we have two types of diode for study in this chapter. First one is the rectifying diode. Second one is the Zener diode. What is diode? Diode is a two-terminal device which allows the current to flow in one direction. This is a symbol of rectifying diode. These are the four types of diode which we have to study. Then the junction diode is also called as the rectifying diode. There are two modes, forward bias mode and reverse bias mode. This is the forward bias mode, reverse bias mode. In forward biasing, current is increasing very slowly with positive voltage of 0.1 volt when you apply at the anode and cathode. At 0.7 volt for silicon and 0.3 volt germanium, the current flowing through the diode is increasing rapidly, called as the knee voltage. So we have in forward biasing, diode acts as a closed switch and very low resistance. In reverse biasing mode, a very small leakage current flowing from cathode to anode due to the minority charge carriers. And when we apply the reverse breakdown voltage like 15 volt, minus 15 volt, then maximum current is flowing from cathode to anode due to the breakdown of PN junction. So this is the diagram. Third quadrant. In reverse biasing mode, diode offers a very low resistance and acts as an open switch. So thank you for watching this lecture. Thank you.